Today we're going to take a look at solving equations with logs. So if you take a look at this first example here, we're going to put some actual numbers to it. So for example, if I had log base 2 of 5 equals log base 2 of x, if our bases are the same, then the argument or the part after has to be the same. So 5 has to equal x. So if we take a look at it this one, you'll notice it's not just a log equals a log. We have two logs on each side. But one thing I notice is they're both log base 3. And if you remember, adding goes back to multiplication. So log base 3 of x times x plus 7 equals log base 3 of 60. So now they're both base 3s. So I have x times x plus 7 equals 60. So x squared plus 7x equals 60. It's a quadratic, so we have to set it equal to 0. All right, so let's do some factoring. So our box and circle, x squared 7x negative 60. So a times c on top, so it multiplies to negative 60 and adds to 7. Let's see, what could that be? Is that 12 and negative 5? So 12x, 7x, x plus 12 plus 7. So this factors into x plus 12, x plus 7 equals 0. So our two answers would be x equals negative 12 and x equals negative 7. So we have to jump back up here. Remember that part after the base cannot be negative. So if I was to put in negative 12, I've had log base 3 of negative 12, and we can't have that. That has to be greater than 0. So that answer doesn't work. It's called extraneous. Oops, I'm sorry. This should be minus 5. I totally messed up here. So minus 5, so x equals 5. But 5 works. Whoops. Oh my gosh, you guys, what a mess. Sorry. So x would equal 5. So our answer would be x equals 5. All right, our second one, solve an equation with logs. Okay, well, we can do this. Well, what do you notice here? Well, logs are on two sides, but we have just a number here, a constant. I can't combine them. So let's get those logs on one side. So let's add log base 2 of x plus 7. So now we have 3 equals log base 2 of 5 plus log base 2 of x plus 7. So we have adding again. So if you remember, adding goes back to multiplying. So log base 2 of 5 times x plus 7. And then it goes back to what we've done before. So the inverse of a log is an exponent. And what is our base right here is 2. So I could raise each side with an exponent to the third. And then I could say equals base of 2 log base 2 of 5 times x plus 7. So raise each side to a power because then our bases are the same. So then I'm left with 2 cubed equals 5 times x plus 7. So 2 cubed is 8. So 8 equals, if I distribute, 5x plus 35. And we can solve minus 35 minus 35. So 8 minus 35 is at negative 27 equals 5x divided by 5 divided by 5. So x equals negative 27 over 5. And again, I have to double check. If I plugged that back up here for x, negative 27 divided by 5 plus 7, that's positive, so we're good to go. All right, example 3, using logs to solve. Okay, so let's see. Divide each side by 3. So I have 2 to the x plus 2 equals 4. So what undoes an exponent is a log, but what would our base have to be on this one? This is base 2. So I can log each side, so log base 2 on each side of 2 to the x plus 2 equals log base 2 of 4, because then base of 2 and base of our exponent, we have x plus 2 equals log base 2 of 4. Now here's the deal. If we said this was no calculator, or calculator, you could type that in and you'd say, okay, how do I solve for x? Subtract 2. So x equals log base 2 of 4 minus 2. But what if I said this was no calculator and this is multiple choice and that's not an answer? So you come up with this and you're saying, all right, log base 2 of 4 minus 2. Well, what am I supposed to do? How do I evaluate this without a calculator? Well, let's take this part right here. What does that equal? So if I expected you to do this without a calculator, you should be able to say, well, this equals something. Who knows what? But I know 2 to something equals that 4, so that question mark has to be 2. So this is equal to 2 minus 2, which is 0. So our answer is 0. Now the next example would be using technology. So, and I don't have the TI Inspire calculator on here, so you'll have to watch the calculator help video on that. But basically in your F1, you're going to type in log of x plus 6 plus 3. In your F2, your second one, you're going to type in 2, and then you find the intersection. And we've been doing that for a while. So if you can graph those two lines and find the intersection, you would be set. Okay, a couple more to take a look at. Let's try these. Okay, well, what do we remember natural log is? Well, that's log base e. So you might say, okay, well, how do I get rid of a base? Log base e is a power. So I'm going to do e to the power on each side. So to the power of 4, e log base e of the square root of x minus 12. So the bases are the same. So x minus 12 equals e to the 4th. Well, how do we get rid of what's the inverse of a square root? We could square each side. So now I just have x minus 12. We multiply exponents, so e to the 4th, and then add 12. So x equals e to the 4th plus 12. Okay, so this next one, let's see. Well, we got to get the exponents by itself, so divide by 9, divide by 9. So 1 over 27, x divided by 3 equals 9. We'll get rid of a log with a base of, or exponent with a base. So log base 1 over 27 on each side. That seems kind of tricky, but we can still do it even though it's a fraction. Of 9 equals 1 over 27 of x to the 3rd. So our bases are the same. So we have x divided by 3 equals log of 1 over 27 of 9. And what's the opposite of divide by 3 is times. So times 3 times 3. So x equals, and again, this whole thing is times 3. So I'm going to put that 3 in front. Log base 1 over 27 of 9. And again, if you had a calculator, you could type this in. But if I said no calculator, you should be able to evaluate this. So log of 1 over 27 of 9 equals some value. So exponential 1 over 27 to something equals 9. Let's see. So this is 1 over 3 cubed equals 9 is 3 squared. We'll flip this on top. So 3 to the negative 3 question mark equals 3 squared. So negative 3 equals 2. So whatever this is equal to 2 over negative 3. So if I plug that in here, so this is 3 times 2 over negative 3. So this is equal to negative 2. All right, in this last one, well, let's see. They're all logs. And remember, there's no base, so it's base 10. So we need to combine these. Okay, well, adding goes back to multiplying. So log of 2x plus 7 times 3 equals log of x plus 6. So now our bases, those are the same, and they're both logs. So I could say 3 times 2x plus 7 equals x plus 6. And now it's a nice linear equation. So 6x plus 21, x plus 6, minus x minus x. So 5x plus 21 equals 6, minus 21 minus 21. So 5x equals negative 15, so x equals negative 3. All right, so then you are going to be solving some of these next ones on the next page.